Hello student, welcome to my class. Last class we have discussed image formed by plane mirror and what is plane mirror, how image formed by it. But today class and this class we are going to discuss a new concept of mirror that is known as spherical mirror. So what is the meaning of spherical mirror? Spherical mirror means it is the type of mirror whose reflecting surface is a part of the sphere. That means suppose we have a sphere here, suppose there is a sphere and its center point of the sphere C and radius of the sphere suppose capital R. Now if we silver one surface, if we silver outer surface or one part of the surface with silver, then the inner part of this part, the inner side of this part is known as reflecting surface. This is a reflecting surface, and similarly if we silver this inner side of a spherical mirror, then the outer surface is reflecting surface. This outer surface is reflecting surface. Clear? Now cut the middle part or cut the central part of the sphere. Now separate it. Now we have two type of mirror, and first one this part, and here this part of the mirror, and this mirror which is a part of this sphere, and its outer surface is silver and the inner surface, and this surface is inner surface, and inner surface is here reflecting surface, reflecting surface, and that type of mirror is known as concave mirror. Concave mirror. And second one, if we discuss this part, then this is the part of the sphere, but its inner surface or inner side is silver, but the outer surface is a reflecting surface. This surface is a reflecting surface, and that type of mirror is known as convex mirror. Clear? But first we will discuss about what is concave mirror and what is convex mirror. So first let's start. What is concave mirror? First, that is concave mirror. Suppose we have a concave mirror here. This is one concave mirror, and the outer surface of this mirror is silver, but the inner surface is reflecting surface. You have to remember this term. Concave mirror means the outer surface is silver, but inner surface is reflecting surface. But convex mirror means the inner surface is silver, but outer surface is reflecting surface. So for concave mirror, this is total part of the concave mirror, and actually this part is and this mirror is a part of this spherical surface, because this spherical surface is hollow spherical surface, just like a glass hollow spherical surface, and this mirror is one of the part of this glass spherical hollow surface or hollow sphere. So here the center of the sphere is C. Now if this is one part of this sphere, and if we complete this sphere like this, then like this point, and this is the central point, we can write this is the center of the sphere, and that is given C, so you can write C here. But in case of concave mirror, the C is known as center of curvature. So what is C? And C is here, that is known as center of curvature. Clear? Okay. Second part, if this is part of the sphere and its middle point, this is middle point of this spherical mirror, and this middle point is known as pole. What is pole? The part of the sphere whose outer surface or inner surface is reflecting surface, and the middle section and the middle point is known as pole. So pole means, that is pole P. Pole means it is the middle point of the concave mirror. Clear? Next, now we have to join a line between pole and center of curvature. Now join a line from pole to center of curvature. This line, clear? And this line is known as principal axis. This line is known as principal axis. So what is principal axis? Principal axis is that axis whose 2 point center of curvature and center of pole are along the same line. Or if we join center of curvature and pole, we get a straight line, and the straight line which is passing through center point of the concave mirror, and this straight line is known as principal axis. Clear? Okay. Now we have to discuss what is focus point, but here we deals with the ray. So you already know what is ray. Ray means it is the path of light. So if you choose one ray here, suppose there is a ray which is infinite distance, which is coming from infinite source. Suppose there is infinite distance and there is a source which emit light all the direction. Now if a ray of light which coming from infinite source and this direction, clear? This is the direction of a ray which is coming from infinite source. But here this the total this is concave mirror. If we discuss about, this is the total radius, and here this total distance, suppose this distance from pole to center of curvature is denoted by r. Or here we can write, what is r? R is radius of curvature, and it is measured from the distance between pole to center of curvature. Clear? If this is a plane mirror, and this is a spherical mirror and concave mirror, and this surface is reflecting surface, this surface is here reflecting surface. Now look at this diagram. If this is the radius of curvature r, and similarly if this is here and here this is radius of curvature r, but because this is spherical surface and this is part of the sphere, so we can draw a curvature here, aperture here. This is known as aperture. This total diameter is known as aperture. Aperture means, suppose this is a concave mirror and this outer surface is silver but inner surface is reflecting surface. This area, this surface area, if where it is a part of the sphere, this total surface area is known as aperture. And this small area, this small radius, suppose r. What is r? R is here, that is radius of aperture. So what is aperture? Aperture means this area, total area from this diameter, from r to this total diameter, and total area is known as aperture of this spherical mirror. Clear? And here r is radius of the aperture. So here this aperture is very small. If we discuss about concave mirror, this aperture is very small, and suppose there is a light which coming from infinite source, or there is a ray which coming from infinite source, and this ray which strike on the reflecting surface of concave mirror at point, suppose M, at point M. We already know, if this point is M, suppose we have a sphere here, we have a sphere, or we already discussed, we already know, if there is a plane mirror, if this is incident ray and we have to draw a normal, then this is angle of this is reflected ray, that means angle of incident which is equal to angle of reflection, angle of incident which is I equal to angle of reflection. We already know about the plane mirror. Similarly, this law of reflection is valid for plane mirror or any type of mirror. Suppose there is a curved surface like this. Now if we incident a ray at this point, then what is the reflection or what is the reflected ray, what is the direction of reflected ray? But in this point we have to first draw a tangent. Now we have to draw a normal, this point which is normal, and this normal which is perpendicular to this tangent. Now this is angle of incident and this is angle of reflection, where the angle of incident which is equal to angle of reflection. Similarly, if we draw a tangent, this center point, this is sphere, if you draw a tangent this point, then if we suppose we have a ray, this is reflecting surface, we have a ray like this, this is incident point. Now we have to draw a tangent. We already know this tangent, this is tangent and this is center of curvature C. If we draw a normal this point, incident point, then all the normal pass through radius and all the normal pass through center of the curvature. So this angle is 90 degree, that means this angle theta. Now this ray reflect at an angle theta. Similarly, if there is a incident ray, if this incident ray incident here, now we have to draw a tangent at that point and we have to draw a normal here, because the normal, the tangent and this normal, but this normal always pass, this normal always pass through center of the curvature, and this angle suppose theta 1, again this surface also theta 1, that means angle of reflection which is equal to angle of incidence. So similarly here, suppose there is a ray which coming from infinite source and striking at point M. Now we have to draw a tangent here, so this is the tangent at that point, clear? And if we draw a normal at this point M, then this normal which pass through the center of curvature or along the radius which pass through this line, this is normal, clear? This is normal, and we already know if this is angle of incidence theta, then the angle of reflection must be equal, and the ray which reflected this direction in this direction and which meet the principal axis or which intersect the principal axis at point F, and this point is known as focus point. So what is F? F is known as focus point. So what is the meaning of focus? That means here we have to choose a, this is small aperture, and this theta and this angle also theta. Here theta is very small. When theta will be very small, if aperture is very small, then this angle theta is very small, clear? And this ray is known as paraxial ray, that is paraxial ray. So what is paraxial ray? The paraxial ray, it is the type of ray which is nearer to the principal axis, which is just nearer to the principal axis due to small aperture. After this paraxial ray incident at point M, and this ray reflected by the concave mirror, and this reflected ray which intersect at a point F on the principal axis, and that point is known as focus point. If we suppose, if we take another ray, if this is ray, this is another type of ray which is coming from infinite source, and this ray which is parallel to principal axis, after incident this point, then it reflected in this direction. It's reflected this direction which meet at a point on the, or which intersect at a point on the principal axis. That point is known as focus. Question may arise, only 2 ray can meet at that point? No. Number of ray. Suppose there are infinite number of ray which is parallel to the principal axis and all ray are paraxial. Paraxial means very close to principal axis. And after incident any of this point on the concave mirror and they pass, and the reflecting surface, the reflecting ray, suppose this is another reflecting ray which pass after reflection or which intersect after reflection at a single point on the principal axis, and that point is known as focus point. Clear? So this point is known as focus point here. Now we have to discuss what is focus or focal length, and this distance pole to F. Suppose this distance pole to F is known as focal length and it's denoted by small f. So what is small f? Small f means focal length. Focal length of the concave mirror. Clear? But we don't need any proof, but we have to remember one thing, that the r here, what is r here? Radius of curvature. And what is small f? That is focal length of the spherical mirror or concave mirror. And we have to remember one term, the radius of curvature r, which is 2 times of focal length of the concave mirror, or this is valid for convex mirror. Now we will discuss about sign convention. Sign convention. So what is sign convention here? First we have to discuss about sign convention. That means if the ray which is starting from this left side to right side, then first point, sign convention, the sign convention of first point, that is pole. This point is pole. So first point of sign convention, that is all the distance should be measured from pole. That is P. That means we have to measure the distance from pole. That means if we measure this focal length, then we have to come from pole to this focal length. Clear? And again, if we measure the distance, that is r, radius of curvature, then we have to measure from pole to and this back side. So all the distance measure from pole. Second point, if we measure the distance, which is opposite to incidence of light, if we measure the distance which is opposite to incident of light, are taken to be negative sign, but if we measure the distance along the direction of light, then along the direction of light are taken to be positive sign. Clear? That means suppose this is the direction of incident ray, or suppose we have a concave mirror here and this is principal axis, and this is the direction of incident ray, this direction. If incident ray left to right, this point is focus point, pole, and all the distance are measured from this pole. Suppose we have a object here, and this is object AB. Suppose we have a object AB here. Now we have to measure the distance AB from pole. Now we have to start the distance measure from pole to this distance. We have to come P to distance, this distance or this object distance, for this is the incident ray which are opposite to each other. If we take this distance, suppose U, because this is object distance, then we have to take here a negative sign. Why? Because these are opposite to the incident ray. Similarly, suppose we have another one object here, that is A dash B dash, and this distance suppose that is U dash. But we know that the distance always measure from pole and this object distance which is U dash. But this is the direction of incident ray, and we have to measure this distance from P to this distance, and which is along the direction of the incident of light. So this object distance taken to be positive. Clear? Next point number 3, the distance, the perpendicular distance, above the principal axis is taken to be, that is positive, and below the principal axis is taken to be negative. That means suppose there is a concave mirror like this, and this is principal axis, and this is, suppose this is center of curvature, and this pole, this is focus point. We already know. Suppose we have a object here, that means the object which is beyond C, and this object which is perpendicular to this principal axis, and if we measure this distance which is above the principal axis, then suppose this distance is h1, and here h1 is positive. Why? Because this distance which is perpendicular to the principal axis and above the principal axis. Similarly, if we take another object here, suppose this object which is below the principal axis, and here the length which is perpendicular to the principal axis h2, but here h2 is negative. Why? Because this distance which is perpendicular to principal axis but below the principal axis, so it is taken to be negative, and this point is taken to be positive. These are most important sign convention for concave mirror and convex mirror also. Clear? Now let's start. What is convex mirror? Now convex mirror, so it is the part of the spherical surface and whose inner side, and this is inner side, and this inner side is silver, but outer side is reflecting surface. That type of mirror is known as, that is convex mirror. If we discuss about convex mirror, suppose we have a convex mirror here like this, and the inner surface is silver, and this point is pole. This is middle point of this curvature, and this is aperture. This is total distance is known as, this total area is known as aperture of this convex mirror. And we already know, because this mirror is a part of the sphere and this mirror is a part of hollow sphere. Suppose this point is, that is this point C, and this point is C is known as center of curvature. Clear? If we join pole and C, then we get a straight line. Suppose this point P here, then this straight line which passing through pole and center of curvature, and this straight line is known as principal axis. Clear? Okay. And this C is known as center of curvature, and this distance which is equal to r is known as radius of the curvature. We already know if there is a light or ray and this ray are paraxial. So you have to remember one thing, what is paraxial ray? So paraxial ray means these rays are very close to principal axis, and this is incident point, the paraxial ray which is coming from infinite source and incident at that point M. Clear? But we have to draw a tangent at that point. So this is the tangent at that point. Now we have to draw a normal by using law of reflection. So if you draw a normal, then this normal which passing through the center of the curvature, if you draw any normal at any point of the sphere, then this normal which passing through center of the curvature, and this is normal, and this angle is known as angle of incident. Suppose this angle of incident I here. According to law of reflection, the angle of incident which is equal to angle of reflection, because this is the inner surface which is silver surface. So the incident ray after striking this point or after incident at point M, it reflect back to the original medium and it reflect back to this direction, and this ray is known as reflected ray, this ray is known as incident ray. After reflection, it seems to like, or suppose if we observe this side, if we observe here, then it look like the ray, the reflected ray which is coming from this point. If we produce back side of the ray, then this produce ray which meet at point F on the principal axis, and that point is known as focus point. Clear? If you take another ray here, suppose there is another ray which is paraxial ray and coming from infinite source, after incident on the convex mirror, if you draw a tangent, if you draw a normal, then this normal which pass through the center of the curvature, and this angle is angle of incident. Now according to law of reflection, the angle of incident which is equal to angle of reflection. Now this ray which reflected to its original medium, and this angle is known as angle of reflection. If we produce the ray on back side, then this ray meet at a point. Clear? Meet at a point on back side of the mirror on the principal axis, and that point is known as focus point. That means all the paraxial ray after incident on convex mirror, they if we increase, if we produce the backside of the ray, then all the rays are meet at a point, common point, and that common point is known as focus point. Clear? And this distance is known as F. F means focal length. We already know that is R equal to 2F. What is R? R means radius of curvature, which is 2 times of the focal length. That means it is same for concave mirror and convex mirror. Why? Because concave mirror and convex mirror is a part of that spherical mirror or spherical hollow sphere. So this is paraxial ray, reflected ray, this is normal here, and this point is also normal. This is case of convex mirror, and this is reflecting case. Clear? Now we have to derive a formula for concave mirror, and that is known as mirror formula. So you already know what is mirror formula, that is 1 by F equal to 1 by U plus 1 by V. What is U and V? U and V, U is object distance, V is image distance, and F is focal length. So suppose there is a concave mirror of small aperture, and this distance, we already know that all the distance are measured from pole. So this distance is known as radius of curvature R, which is equal to 2F, and this distance is the distance between P to F is known as F, that is focus or focal length. Suppose there is a paraxial ray, the ray which is coming from infinite source, or you can take the ray suppose there is a object and this object is known as length object because it consists from length, and the length object which is perpendicular to the principal axis and above the principal axis. Suppose this object A and B, and if we draw the ray diagram of this object, then the ray which is coming from at point B and strike suppose at point M. After striking at point M, it reflect back because we have to draw a normal, and this normal which is passing through center of curvature, and angle of incident which is equal to angle of reflection we already know, and this ray which pass through this point and the ray which pass through this focus point. You have to remember this diagram. That means the ray which is parallel to the principal axis, after incident on concave mirror, the reflected ray which pass through the focus point. Clear? Okay. Again, we already know that if another ray, if we take another ray from this point B, then suppose this ray which passing through center of curvature, this direction. Now we have to draw a normal at this point, and this is incident ray. This ray is incident ray which passing through the normal, which passing through center of curvature at point C. Now we have to draw a normal at this point. If we draw a normal this point, then the normal is along the direction of incident ray. That means the angle of incident which is equal to 0 degree. So angle of reflection also 0 degree. That means if the ray which passing through center of curvature, after reflection this point, it trace its original path. That means it reflect back to this same direction than incident direction. Clear? So this is first ray and this is second ray. The intersection point of first ray and second ray and this point which make a image. So this is the formation of image at this point. This is image form. Clear? This is object AB, and this point A, we can write this point which is equal to A dash, and this point B, and this point we can write that is B dash. Clear? This is image distance, this is image, and this point is object. Clear? But here we have to find a mirror formula, and this distance is object distance. So we can take this distance from pole to object which is known as U, and this distance from pole to image, that is distance is known as V. So what is U? U is here, that is object distance, and all the distance are measured from pole, and this distance is, that is image distance. Clear? Now we have to draw a normal from point M which meet on the principal axis. This is normal from point incident point M which meet the principal axis at point N, and this angle is 90 degree. And here the point N and point P are very close to each other. Why? Because here we use a small aperture. So first look at this point ABC. If we discuss or if we prove, then in triangle there is two triangle ABC. Look at this triangle ABC and triangle ADS-BDS-C and triangle ADS-BDS-C. These two triangles are similar. Why? We suppose this angle theta, then this angle will be theta, and here this angle is 90 degree, and here this angle also 90 degree. So this which satisfy the congruence condition. So these two triangle are similar triangle. Triangle ABC and triangle ADS-BDS-C are similar triangle. So you can use the formula, that is AB, the distance AB divided by object distance, that is object distance divided by image, that is ADS-BDS. AB by ADS-BDS which is equal to AB, because this point C which is common for both the triangle. So this distance AB by A dash B dash divided by SC divided by SC divided by A dash C, SC divided by A dash C. Now we have to write, but given that the object distance U here, the image distance V here, center of curvature as equal to F, and the focal length which is equal to F, but this distance is not given. So first we have to convert this distance in terms of object distance. So this distance can be write, this distance is SC, and SC can be write this distance minus this distance. That means SC can be write AN, because AN which is equal to AN minus, that is CN, AN minus CN divided by A dash C, A dash C, this distance. That means first we have to find this distance, that is CN minus we need this distance which is equal to A dash C. So CN minus A dash N, CN minus A dash N, since the point N is very close to point P, very close to point P. So we can write that is AB divided by A dash B dash, which is equal to AN. AN can be write, that is AN means AP, that is AP minus CN, CP, that is CP, because N and P are very close to each other. We can replace N in terms of P, and this point equal to CP minus, that is A dash P. This is equation number 1. Clear? Again we have another two similar triangle. Look at this diagram. Suppose this angle theta1 and here this angle also theta1, and if we take again in triangle, which triangle? A dash B dash F, and triangle A dash B dash F and triangle that is MNF, that is MNF are similar triangle. So if these two triangles are similar, then we can write that is A dash or MN, this point MN, that is MN divided by A dash B dash, that is A dash B dash, which is equal to MN, because this F which is common point. Now this distance, that is FN divided by this distance A dash F, which is equal to A dash F. Or we can write that Fn can be write Fn, because here n is very close to P, so we can replace n in terms of P, that is Fp divided by A dash F, this distance A dash F. But how can we find this A dash F? Now first we have to find this distance, that means A dash P. If we subtract, that is Fp, then we get this distance. So the A dash F can be write, which is equal to Fp divided by this distance, that is A dash P minus Fp, A dash P minus Fp. This is equation. Or what is Mn? Here the object distance Mn, here AB which is equal to Mn. This distance and this distance are equal, because this ray which is parallel to principal axis. So you can write this Mn in terms of AB, AB divided by A dash B dash, which is equal to, that is Fp divided by A dash P minus Fp. This is second equation, and this equation is first equation. There is two equation, equation number 1 and equation number 2. Now we have to use sign convention. So we can write here, that is sign convention is important for optics. So first we have to find distance Fp. Now we have to find distance Fp, then that is Cp, and again we have to find distance Cp, next A dash P, and distance here, that is A dash P, and here that is FP, and again we have to find distance, that is FP, and that is radius P also here, FP. Okay, we have to find this distance using sign convention. What is AP? The distance A to P, and this distance is object distance, but we have to measure the distance always from pole, and here the light which is coming from left to right, this direction, but distance always measure from pole. So we have to start this distance, we have to start distance here, now we have to come this direction to measure the object distance, but object distance this side, then ray of light this side, which are opposite to each other, and here AP which is equal to minus U, negative sign. Again CP means this distance which is equal to R equal to 2F, but this is the direction of incident, and we have to measure this distance which is opposite to incident, or we can write that is minus R, or which is equal to minus 2F. Similarly radius P, this distance is known as image distance. Object is left side, object is coming from left to right, but image always measure from pole to distance, always measure from pole to that distance. So V always measure from opposite to opposite to incident ray, that is minus V and this term is minus V. Again what is FP, or this FP distance is focal length F, and distance always measure from a pole, that means all the distance are opposite to incident of ray, that means this distance also minus F. If we use this relation from here in equation 1, if we use this concept here, or if you compare equation 1 and 2, comparing equation 1 and equation 2, you can write LH side here, LH side equal, then right hand side must be equal, that is AP minus CP divided by CP minus radius P, which is equal to FP divided by radius P minus FP. Clear? Now we have to use this relation here. So if we use this relation here, the AP, the value of AP which is equal to minus U, negative sign of CP which is equal to minus 2F, that is minus 2F divided by CP which is equal to minus 2F, it is minus 2F minus radius P which is equal to minus V. So this is minus V which is equal to FV, but FV here that is minus F, that is minus F divided by radius P equal to minus V, that is minus V, negative sign here, and this is FP, and FP which is equal to minus F. So here minus F. Now solve this relation and you will get a final answer. So if we write this relation, that is minus U minus minus plus, that is 2F divided by minus 2F minus minus plus, that is which is equal to minus F divided by, that is minus V minus V minus minus plus F. Now solve this relation. Okay, if we multiply this here, then you will get, that is minus 2F square plus, that is minus minus plus, and minus plus here minus, this term is minus, this term is plus, that is FV, and here FV which is equal to, now this term we have to multiply this term here, that is minus V plus F into the remaining part, that is U plus, that is 2F. Now solve this relation which is equal to 2F square minus FV which is equal to minus V minus U minus minus plus, that is UV, next minus plus minus, that is V2F, that is 2VF plus minus, that is FU, because plus minus minus here, again plus plus plus, which is equal to 2F square, that is 2F square. Look at this relation, here 2F square and here 2F square cancel, then the remaining part, that is minus FV which is equal to UV here UV, that is UV minus 2vf minus fu. So here minus 2vf and here vf, minus 2vf, here minus vf. If we take this side, then minus fv which is equal to plus 2fv which is equal to uv minus, that is fu or uf, and here the remaining part, that is 2vf minus vf, that is vf which is equal to uv minus fu. Now divide uvf on both sides. Now dividing uvf on both sides, we can write, that is fv divided by uvf which is equal to uv divided by uvf minus fu divided by uvf. Clear? So here fv cancel, uv cancel, and here fu cancel. The remaining part is here, that is 1 by u. So 1 by u which is equal to 1 by f minus 1 by v. 1 by v here, and if we take 1 by v this side, then this term will be, it is 1 by f equal to 1 by u plus 1 by v. Clear? This is the relation between f, focal length, object distance, and image distance of a concave mirror. So this is the mirror formula. You have to remember this formula by using this sign convention. Now we have to draw ray diagram which is showing different object position. Now we have to calculate the image position at that situation. So first case, when object is at infinite distance, that means here the object which is situated at infinite distance, suppose this distance is infinite distance from pole, and the object which is at infinite distance, the ray which is coming from this direction, which is paraxial ray, and after incident on the mirror, then it reflects and it pass through the focal point. Similarly, if object at infinite distance, we can take another ray also. If this ray which is passing parallel, if this ray which is paraxial and parallel to the principal axis, after incident on plane mirror, it reflect and meet at a point on the focus point at principal axis, and this point is known as focus point. But here image the object which is situated at infinite distance, and here the position of object first point which is at infinite, object which is at infinite, but the position of image which is at focus point F, and here nature of the image, and here the nature of the image, that is point size, real and inverted. Very small size of object. Real means actually these two rays are really meet at point F, so they form a real image. So second thing, object between infinite and C, that means this is infinite point and this is C. Suppose there is a object AB which is in between C and A, the ray which is from point C and parallel to the principal axis, after incident on plane mirror, after incident on concave mirror, it reflect and pass through the focus point. Next ray, if we draw another ray, suppose there is a ray, if this ray which is passing through the center of curvature, this direction, the ray which is passing through center of curvature, if we draw a normal this point, then angle of incident, this is incident, and normal also along the same line, the angle of incident and angle of reflection are equal, and here angle of incident is 0, so angle of reflection is equal to. So the ray which retraces to its original path, then we get a reflected ray like this direction. After this is the intersection point of first incident and first ray and second ray, so we get an image here, and this point is known as image, and this point A and this dash, there is A dash, B dash. So if object between C and F or beyond C, then we get a image which is less height or which is less distance as compared to object distance, and the image formed in between C and F. That means here object between C and infinite, then image formed between C and F, between C and F. Here the size of the image, that is diminished. Here diminished size, that means small size of the image as compared to object, and here the ray are actually meet, so it form a real image, and the object which is upward direction but image downward, inverted. Clear? So we get diminished image, real and inverted image. Next, third point, when object is at C, if there is a object lies on point C, now this ray which is parallel to principal axis, after incident it passed through the focus point, pass through this focus point, and like this. Clear? Again, if we take another ray, the ray which passed through the focus point, and again after reflection through the concave mirror, then it reflect parallel to the principal axis. Why? Because the parallel ray incident, after incident it passed through focus point. Then similarly the ray which passed through focus point, after incident the reflected ray which is parallel to the principal axis, like this direction. Clear? So we get a image here, this point and this point image like this. That means the image, the object is at C or center of curvature, and we get a image at also C. If object distance is 2 meter, then image distance also 2 meter, same size of the object. But here this point A and this point B and this point A dash and this point B dash, just they are inverted to each other. This is object and this is image, like this. So here we get a real image, that is real image and inverted, but same size. Next, if object in between C and F, suppose there is a object between C and F, the ray which is parallel to principal axis, after incident the reflected ray pass through focus point. Clear? Okay. Again, if we take a ray which is passed through the focus point, after incident on concave mirror, it reflect parallel to this direction, parallel to the principal axis. Why? Because the parallel ray after reflection on concave mirror which passed through focus point, similarly the ray which is passed through focus point after incident this point which is parallel to principal axis, and here the image form like this, and here object, that is AB object, and this is image and this is object. Clear? That means if object at between C and F, then the image form beyond C, that is between, or you can write between C and infinite, or beyond C. That means the object image form beyond C or C and infinite when object is between C and F. But here the image is magnified. Magnified means large size as compared to object, and here also real image, because the ray are really meet this point. So this image is real image and inverted, which is just opposite to this is inverted. This is object and this is image in this direction. Clear? Next, when object is at F, if we place a object F here, then the ray which is parallel to principal axis, after incident the reflected ray pass through the focus point like this. This is focus point. This is the reflected ray in this direction. Clear? Again, if we take the pole point, if we incident a ray at point pole, then this angle is theta, and it reflects back with same angle. This angle theta, this angle also theta. Clear? So we get a image at infinite distance, and which is large image as compared to object, because this is object and this is image. These two rays are parallel, or we may think that these two rays actually meet at infinite distance. So image formed at infinite when object at focus point. So when object at focus point, the image formed at infinite, and this is magnified very large or highly magnified as compared to object, and this image is real image and which is inverted image. Clear? Last case, which is important case, and here object is placed between F and P. Here F and this point P. Suppose there is a object here. This is object O, and the ray which start this point, after incident, this ray pass through the focus point like this. If we produce the ray, then this is the produce of the ray backside of the concave mirror. Clear? Again, if we take another ray which strike at pole, suppose another ray which strike at pole, because for image we need minimum 2 ray to observe a image. Suppose this angle theta, now the ray like the reflected ray and also pass at an angle theta, angle of reflection. Clear? From the law of reflection, if you produce this back side, if you produce this ray on the back side of the concave mirror, then we get a mirror, we get a image which is back side of the mirror, and here this object which is above the principal axis, and here also objects which is above the principal axis. Actually these rays are actually not meet at a point. If we produce on back side of the image, then virtually they meet. So this image, when object is in between, that is F and P, then we get a image which is back side beyond, or that is back side of the mirror. Clear? This is back side of the mirror, and it is large as compared to object, that is it is magnified. We get a magnified image, and this image is not real. Why? Because this ray are actually not meet or actually not intersect at a point, they are produced image form. So here we get a virtual image, and again this is object and this is image, and same side of the principal axis, so it is erect. Clear? This is first case, second case, third case, fourth case, fifth case. We get a real image. Clear? Real image, real image, real image, real image, and real image. But last case we get a virtual image, and which is real, virtual and erected, and it is magnified image. So you have to remember all these conditions. What is the condition for which we get a real image, and what is the condition for which we get a virtual image? And this type of virtual image we cannot place on the screen, because this is virtually meet, or this is the produced ray meet at the back side of the mirror, and which is a virtual image, and this is magnified, virtual and erect. Clear? And this is the sixth important case for concave mirror. From this table we conclude that when object at infinite, that means when object at infinite and coming towards center of curvature, then image it at focus point. When object at infinite, image formed at focus and this point. When object come to this side, that means here object at infinite, again object come towards the focus, then image like this. Clear? And when object reach at center of curvature, and image also reach in this direction. Clear? This is the direction of image like this. That means here the image size increase, and it is same size of the image and object when object is at center of curvature. Now if object in between C and F, because this is F point, this point is F point, when object in between C and F, then image also increase this direction, and when object reach, because this point is F point, when object reach this point, not at point F, at that time the image which is at infinite this distance, and here we get a large image as compared to this object, when object this point just nearer to the focus point but beyond the focus point. Again when we reach this after, or when we reach beyond the focus point, but this point, this direction, and this is this is right direction and this is left direction, when object reach right direction of the focus point, then image start at infinite, but this image start at infinite which is virtual, and here image start in this direction. Clear? Why? Because when we reach at F, then image is at infinite. There is 2 point, that means just left side and just right side. When the object just left side of just left side, suppose this focal length of the mirror is 10, and this image, this distance is just suppose x, suppose object distance, this distance is u, and suppose u equal to 10.000001 this distance, then at that time we get a image which is minus infinite, because distance always measure from pole to this point. So here this is the direction of ray coming from left to right, but image which is coming from the image distance which is coming from this is left to right, this is right to left, and this is negative sign. And when we reach this distance, suppose this distance u equal to 9.999999, at that time the image start at positive infinite. So there is 2 point at F, when just above and when just less. Again when the object in between F and C, in between F and P, this point F and P, back side of the mirror, and this is back side of the mirror, we get this direction. Clear? When another last point, when object is at pole, then image also at this pole. Clear? Okay, when object, if we place a object here, and this object is known as virtual object, this is not real object, this is known as virtual object. So for virtual object, then we get a image in between F and C. You have to remember this condition, in between F and C. When virtual object at infinite, that is positive infinite, then the image at this point just less than the focus point, this point. So this is the ray diagram of the concave mirror. Clear? This is the ray diagram. Or already we discussed the mirror formula, that is 1 by F equal to 1 by U plus 1 by V, and this focal length of a mirror which is constant quantity, and this quantity is constant, but here this is focal length and this distance is minus F, because distance always measured from this pole, and this focal length is minus. If we use sign convention, or we can write here, that is 1 by F equal to 1 by V plus 1 by U, and this is negative sign, so 1 by F equal to 1 by V plus 1 by U. Or we have a relation, that is y equal to mx plus c, which is straight line equation. Clear? Or you can write this point is suppose y plus x, which is equal to a constant quantity, and here this constant is negative, because focal length of a mirror, focal length of concave mirror always negative, and this is the case. If you draw a graph, that is u versus 1 by v versus 1 by u, then the graph like this, this is x axis and this is y axis. Clear? When x equal to 0, then y equal to minus c. When x equal to 0, y equal to x equal to 0, it is y equal to minus c. And this point again, when y equal to 0, When y equal to 0, x equal to minus c. When y equal to 0, it is x equal to minus c. Y equal to 0, x equal to minus c. This point. If we join this point, then this is a straight line. And here 1 by v, because we take this is y, this point is y, and this point is u. Clear? So here 1 by v and here 1 by u. This is the 1 by u and 1 by v graph. And here that is v. So here v is positive, and this quadrant, first quadrant, second, third, fourth quadrant. First quadrant v positive means v positive. That is v positive when this is the v positive. This means here image. So we get a virtual image back side of the mirror. So here we get a virtual image. This is virtual image. But object, here object is negative, and here u is negative. U is negative means u is negative means front side of this reflecting surface. So here this is real image. This is real object. And here focal length is always negative. And this point v is negative, that is u is negative. V negative, u negative. That means this side here v negative and u negative, and here we get a real image. And this point is here object, this is positive, that is u positive and v negative. When u positive, this is object distance u, and here u is positive quantity. Why? And this is known as virtual object. So here virtual object and image, this is negative image, this side real image. Here real image and real object. Here virtual image and real object. This is the graph between 1 by u and 1 by. Now we have to draw a ray diagram for convex mirror. Clear? So convex mirror, and this is center of curvature, this is focus point. Suppose the object which is at infinite distance and the ray which is coming from infinite and parallel to the principal axis after incident on this point, then we have to draw a normal which is passing through the center of curvature and this angle of incident. According to law of reflection, the angle of incident which is equal to angle of reflection, and the ray which is reflected back this direction, this is reflection ray and this is incident ray. This is angle of reflection r. Clear? That means if we observe this side, the ray which is seems to just coming from this point and just coming to this focus point, or if this is reflected ray, if we produce its image or if we produce its ray a back side of the convex mirror, then the produced ray which meet at point the focus point. Clear? Similarly, if we take another ray here, suppose this is ray, and here also we have to draw a normal, and the normal which is passed through this center of curvature. This is angle of incident, and this angle of reflection, and here this is angle of reflection r. If we produce this ray, then which meet at a point C. Clear? That means when object is at infinite distance, then position of the point which is focus at F, and here the rays are actually not meet, or the rays are not meet, really not meet. So we get a here, that is virtual image. This small size or point size, and this is not real image, this is virtual image. And diminished, virtual and erect image. Suppose when object in between infinite and p, infinite and p, that is at infinite and p, then if you draw a ray diagram here, then this ray is reflected this direction. If you produce, then this point is passed through the focus point, and another ray, suppose if you take another ray which incident at pole this angle theta, and reflect back the same angle with theta this direction. If you produce this ray, then this is the image. Clear? And this is object and this is image. and here also we get image in between F and P, because this point is pole point, in between F and P, and here also we get a virtual image that is small or diminished. We can write diminished size, and here that is virtual image, and this is smaller size and erect, because this is object, and here also image which is as erect. Clear? This is the case for image formed by a convex mirror. You can prove the mirror formula by from this concave mirror also, and you can prove this relation. We will get that is 1 by F equal to 1 by V plus 1 by U. That means mirror formula is same for both concave mirror and convex mirror. Clear? This is the mirror formula for convex mirror, but here the distance always measure from the pole, this distance, and here focus point, and this focus point always positive. So you have to remember, for concave mirror the focal length F which is always negative. For convex mirror the focus that is which is always positive sign. Clear? So this sign is positive sign, and this sign is constant quantity, because the focus suppose 10 and 10 centimeter, which is a constant quantity of this focal length of the convex mirror. Or you can write that is y plus x, which is equal to plus c, because here focus is positive. If you draw a graph, then the graph will be like this. Suppose if you draw graph here, then the graph like this, here y axis, and this axis x axis, here 1 by V, that is 1 by U. Clear? This point origin 0, 0. Now when y equal to 0, x equal to plus c. When y equal to 0, x equal to plus c. When y equal to 0, then x equal to plus c. This point is c along x axis. Similarly, when x equal to 0, y equal to plus c. This point, when x equal to 0, y equal to c. If we join the line, this is the line. Clear? This is the graph of 1 by V versus 1 by U graph. Now let's start magnification. So what is magnification? Magnification is the measure of distance or relative distance between object and image. So we will discuss here, that is a linear magnification. So what is linear magnification? It is the ratio of image distance or size of image as compared to size of object. That means it's the ratio of image distance divided by object distance is known as magnification, and it is denoted by m. Suppose we have a concave mirror. For first we will discuss concave mirror, and for concave mirror, suppose we have a concave mirror here. This is concave mirror, and this is axis, principal axis, and here this point is P, and this point is C, and this point is here A point. Clear? Suppose there is a object which is beyond C, and this is object, and suppose this other ray which is parallel to principal axis, after incident, after striking the mirror, it reflect and pass through the focus point. Clear? Similarly, if you take another ray which incident at pole, and this angle is theta. Now this is normal, and here the principal axis is normal for this incident ray, this ray. Now this ray is comes to this direction, and which meet this point. Clear? This is image, and this angle also theta is here. For magnification, that means height, image distance or height of image divided by, or you can write that is height of image or size of image, that is height of image divided by height of an object. Suppose here the height of image, that is h1, and height of image, that is h2. So here magnification m in case of concave mirror can be write which is equal to height of image, that is h2 divided by here height of image h2 divided by height of object, that is h1. But here we have two triangle. Suppose this point A, B are object, and here A dash B dash is image, and this point P. There is two triangle A B P and triangle A B P and triangle, which triangle, that is A dash B dash P. Triangle A dash B dash P are similar triangle. Why? Because this angle 90, here this angle 90 degree, and this angle is theta, this angle is theta. That means these two are similar triangle. For similar triangle we already know, that is AB divided by A dash B dash, which is equal to AP divided by A dash P, A dash P. But AB, what is AB? AB means height of object. So you can write H1 divided by A dash B dash, that is H2, which is equal to. But here you have to remember one concept here, that is object which is above the principal axis, and if you use sign convention this is positive, but image which is below the principal axis and it is taken to be negative. Again, that is AP means object distance, and this is object distance always measure from this pole and ray of light which is this direction. That means these are opposite to each other. So this object distance is minus u. So you can write here minus u divided by A dash P. A dash P, similarly this distance which is equal to minus v. That is minus v. Minus minus cancel. So we can write that is h2 by h1 which is equal to minus v by u. And if you use this relation here, that is minus v by u is magnification for concave mirror. If you draw a convex mirror here, suppose this is convex mirror and this surface is silver, and here suppose one object, and this object is AB, and this point is center of curvature, and this point is focus point. The ray which is parallel to principal axis, after incident it passed, it reflected this direction, and if we produce ray which passed through the focus point. Similarly, if we take another ray which incident at pole, because this point is P and here this angle is theta, and now this angle is also theta, this is reflected ray. If we produce the ray or backside ray, then the virtual ray which meet at a point, and this point is known as A dash and B dash. Clear? And this image is known as virtual image. And here magnification, that is M equal to height of image, and here height of object h1 and height of image h2. So you can write that is h2 by h1. This is first concept. This is magnification, height of image by height of an object. But these two triangles are similar because this angle theta and here this angle also theta. So there is a triangle, this point is P. That means in triangle ABP triangle and triangle, which triangle? That is A dash, this point B dash, A dash B dash P. This triangle, that is A dash B dash P triangle. These two triangles are similar. So you can write AB, that is AB divided by A dash B dash, that is A dash B dash, which is equal to this distance, and this distance AP divided by this distance is PA distance. If we use sign convention here, then you can write it is AB means object distance, and object, because this is ray, this is direction of ray, and here object, and here minus sign, and object which is we don't here object AB, this height, and this height which is above the principal axis, and this point is plus, that is h1. Clear? AB distance which is plus h1 divided A dash B dash. A dash B dash also plus, because these two object and image are above the principal axis are taken to be positive by using sign convention, which is equal to AP, and this distance AP, but ray coming this direction, but distance measured from this direction, and here this is minus u divided by PA. PA means this distance which is V, because this distance is measured along the direction of the incident light. So this distance is P. That means h1 by h2 equal to u by v, negative sign, and h2 by h1 equal to minus v by u. If you use this relation here, which is equal to minus u by v. Clear? This is magnification for concave mirror, and this is magnification for convex mirror. Clear? This is all about how image formed by concave mirror and convex mirror. What are the mirror formula, and what is magnification of concave mirror and convex mirror. What are syllabus? Plane mirror and this spherical mirror excluded. So this is the first lecture and this is second lecture. First lecture and second lecture is not included to your syllabus, but this first lecture and second lecture which help you for your higher study. So you have to focus this first lecture and second lecture. First lecture details about plane mirror and second lecture details about spherical mirror.